All right, thanks for tuning in again. Brandon Clayton, the Algebra Guy here. Our discussion today is a very popular one, multi-step equations with variables on both sides. Can you solve them? What if there's an x or a y on both sides of the equation? How do you go about that? What do you do first, second, third, and so on? Let's get into that to dispel whatever myths and clear up any understanding. So by the end of this video, you will be able to solve an equation with constants on both sides, variables on both sides, variables and constants on both sides, and using a general strategy. So let's jump in there and see how we can do this. So let's start out with our problems. So before we did problems where we just had constants on one side and variables on one side. But we're going to jump into variables being on both sides in just a second. So let's start with these. So I want to get x. Solving an equation means I want to find out what the value of x has, what does the value of x need to be in order to make this equation true. 4 times what number plus 6 is going to equal negative 14. All right, so to solve that, we need to get this x by itself. Now, a lot of times individuals have difficulty knowing what to do first. And truth be told, it doesn't matter what you do first, as long as you do the same thing on both sides. However, there is something that you can do that makes it easier than harder. So, and I'm going to show you this. So first we talked about working our problems using PEMDAS. So on the left side, like if I'm looking at this, I'm using PEMDAS. I think to myself about the variable I'm looking for. Does it have any parentheses? No, it doesn't. Any exponents? No. So I'm going down. PEMDAS, multiplication and division. Yes, it's being multiplied by 4. So I'm going to make a little note here on the left side that says it's being multiplied by 4. This little dot is multiplied. Is there anything being added to x? And I'm going to say yes. There's a 6 been added to it. So in order for us to understand what comes first, we're going to have to go back up PEMDAS. We're going to have to undo or find the inverse of all the operations we just did. So instead of adding 6, what do you think we're going to do? Good. I hope you just said minus 6, subtract 6. And instead of multiplying by 4, we're going to divide by 4. So let's go ahead and do that now. So let's look at our blueprint over here. And we start from the bottom and we subtract 6 first. So I'm going to subtract 6 on both sides, leaving me 4x equals, because this is 0, 6 minus 6. Negative 14 minus 6 is negative 20. Okay, I'm stuck. What do I do next? Oh, I already did my negative 6. Now I divide by 4. So I'm going to divide by 4 on both sides. And that gives me a negative 5. So that's what x has to be in order to make this equation true. So that's one way you can think through your problems is really undo the PEMDAS operations, right? So we put it together with parentheses, exponents, multiplication, division in that order. Well, we need to undo everything. I'll undo all those operations. All right, so what about this one? If I kept this same model, and I'm not going to keep putting this up here because it takes a little bit of time, and I want you to get used to doing it without it, but use it if you need it. So I'm solving for y. It doesn't have parentheses, doesn't have exponents, but it is being multiplied by 2 and subtracted by 7. So I'm going to go up and undo that over here just to give myself an idea of what I need to be doing. I need to add 7 and dividing by 2. So I'm going to start by adding by 7, adding 7, and that gives me 2y equals 15 plus 7 is 22, and then dividing by 2. That leaves me y equals 11. And there you go. All right, so let's try it again. This time I definitely want to encourage you to jump in here, pause it, and see if you can work this yourself. I got variables on both sides this time. Now, one of the first things I want to do is get all the x's on the same side because I need it to say x equals something, not x equals another x. So first thing I'm going to do is subtract 4x on both sides because I want to do 5 minus 4 is x. And then this is 0, and that leaves me 7. So just doing that one move gave me a 7. And for those who are wondering right now, I put a line through the 7 by habit to differentiate it between a 1 or L or any other number. or character. So that's just x equals 7. All right, so we saw for that one. What about this one? I need to get all my x's, the y's on the same side. Now, it doesn't matter which side. I've seen some teachers strictly teach getting the variable on the left side. However, that's not necessarily what you have to do. You can get it on any side. I actually prefer to put the variable on the side to keep it positive. So if, for instance, if I subtracted 7 to y and subtracting 7 to y, I notice in my mind that 5 minus 7 is going to give me a negative 2y. And I'd rather not have a negative. And you could do that and have it like set up like this. You're going to have to add 8 on both sides again. Or not again, but add 8 on both sides. And then divide by negative 2y, which gives you a negative 4. So you could definitely do it that way. And just to show you, I'm not going to show this every time, but to show you, it doesn't matter which order or which side you put the y is going to work. So what if I would have subtracted 5y instead? Then I have negative 8 equals 2y, and I would divide by 2 on both sides. Y equals negative 4. Now, is that less steps? Let's see. 1, 2, 3. It feels like less steps. Maybe it's the same, but this way I just prefer to do it because keeping it positive. I like to keep things positive. We just did that problem. Let's do this one. So again, I would encourage you to do this for yourself before I do it. There's nothing I can combine over here. That's another point I want to make. Don't make the mistake of thinking this is 12 or 12x, because you can't put these terms together. There are two different terms. X's and just numbers or terms that don't go together. Now, if there are x's and x's, yeah. And don't make the mistake of trying to add 7x and 6x, because you can only add variables or like terms when they're on the same side of the equal sign. It's kind of like I had a balance. And if I had 2 pins in this hand, 1 and 1, I could just close the hand and say I got a total of 2. But I can't have a pin and a, let's say, a stapler. This is a stapler. So I can't have a pin and a stapler and say, hey, how many you got? I got a stapler and a pen. I'm going to have to say that I have one of each. One pen, one stapler, because they don't combine. They're completely two different terms. So I'm going to have to remember that when I'm thinking about combining across the equal sign. So this would be the equal sign. One hand's here, one hand's here. You can grab one hand and put everything together, but you can't cross that equal sign and combine like terms. All right, so what can we do? We can bring these x's to the same side, and I'm going to subtract 6x to do that on both sides. So that gets rid of that one on that side. So 7 minus 6 equals x. Now I have plus 5 equals 2. Want to get rid of my 5 by subtracting 5, and now I'm left with x equals negative 3. Again, want to bring my variable so that they're on the same side. This time I have to add 3, and that gives me 9n minus 2 equals 7. What is that number I just drew? Equals 7. There we go. Now I want to get my n by itself. So there's two numbers I need to get rid of over here, a negative 2 and a 9. Which one goes first? Well, according to PEMDAS, the AS is on the bottom. I'm going to start with the A and S, which is addition and subtraction. So I'm going to add 2 on both sides, leaving with 9n equals 9. And then I'm going to divide by 9. N equals 1. All right, what about this one here? Let's get the variables on the same side. I'm going to subtract 2a. Subtract 2a. That's a subtraction. And that leaves me 0 over there. Equals 5 minus 2 is 3a plus 8. I still need to get the 3 and the 8 from over this side so I can get a by itself. So first I'm going to subtract 8, again, because we want to deal with our addition and subtracting when undoing. That's a lot easier. Leaves us 3a minus with a negative 15. Divide by 3 on both sides, and we're left with a equals -5. Fantastic. What about fractions? We're going to do the same thing, same basic concepts, but sometimes we don't like to see fractions, but still use the same concepts. 3 over 2, 1 over 2. Fortunately, they both have the same denominator, so they should be pretty easy to add. So it's kind of just like saying 3 and 2. 3 and 1. So I'm going to subtract 1/2 x over here, subtract 1/2 x. Now, something else I just thought about that I want to point out. Notice I said minus 1/2 x, because I'm going to get rid of this whole thing. Students often in their haste or laziness or just absent-mindedness will forget to put the x there and just say minus 1/2. But that's a number. This is not, that's just a constant. We want the whole coefficient and variable with this. So we subtract all of that. So what is 3 minus 1? Well, that's just 2 over 2. Actually, that's not. Yeah, 2 over 2. 2 over the 2 is the same thing as just 1x. So I'm just going to put an x here. So this actually crosses itself out. Now I got plus 5 left. And this goes away because that's 0. And this is equal to -3. Now this becomes real simple, right? Because now I got to subtract 5 on both sides. X equals -8. And we're done with that. What if you have decimals? You're going to do it the same way. Please do this decimal before I work it. First, I'm going to combine my like terms. Subtracting 1.6x, subtracting 1.6x. That's going to leave me with a 2, 4, 8, and 2.8. X plus 4 equals -5, because these cross out to 0. I need to get rid of this 2.8 and 4, so which one goes first? I hope you just said 4. There we go. So now I'm left with 2.8x, because that's 0, equals -5 minus 4 is -9. And last step is to divide 2.8 and -9. So I'll take out my rusty trusty calculator. 9 divided by 2.8. And we'll have to round here. So this goes away. This is just x equals 3.214. You don't have to go that far, but I went far enough. I should say approximately, because it's not exactly equal, because we're not taking into account all the numbers. And we can't forget one thing. What did we forget? The negative sign. So that's a little piece that tends to mess me up sometimes, as I almost forgot. But I always like to look back at the problem and see if it makes sense. And that's when I saw this negative sign. So there should be a negative there. All right, so let's work this one by doing 3 times x is 3x. 3 times 2 is 6, equals 18. So subtract 6 on both sides to get closer to getting this x by itself. And I get 12 people. Divide that by 3. X equals 12 divided by 3, which is 4. All right, so on this one, we're going to treat this negative like a -1. So -1 times x is -x. -1 times 5 is -5. Equals 7. So here I can, well, first let me add 5. That is an ugly looking 5. Add 5. And I'm left with -x equals 12. So I need to get rid of this negative, or really there's a -1 here. So there's two things I can do. I can multiply both sides by -1 or divide by -1, because they both have the same effect of changing this to a positive. I'm going to multiply by -1. So now I got x equals 12. All right, we got 4 times x, and 4 times -2 is 4x minus 8 plus 5 equals -3. Combine some like terms here. Did you see that? So then we end up with 4x minus 3 equals -3. And now I got to get my x by itself by adding 3. on both sides. And that gives me 0. And 0 is a number. Don't be dismayed when you see a 0 as if something happened wrong. 0 gets so sad and lonely because nobody wants to play with him. And everybody dismisses him as a real number. But he is a real number. So let's treat him like that. So we're going to divide both sides by 4. And that gives us x equals 0 divided by anything is 0. All right, -2. We're going to do the distributing first. -2 there. -2 times 3y is -6y. And -2 times 5 is -10 equals 0. And we just have our 8. Nothing to combine. Or actually, we can combine our numbers, 8 and -10. So we end up with -6y minus 2 equals 10. I'll add my 2's and divide by a -1. I told you it doesn't matter. On this one, it might, actually I forgot my y, didn't I? 6y equals -12. And one last step, we want to divide by 6. Divide by 6 gives us y equals -2. Voila! Whoa, it's getting a little bit longer. So you got to remember your order of operations and just go step by step here. We're going to distribute and distribute. So 3 times x is 3x. 3 times -2 is -6. We're left with a -5 equals 4 times 2x is 8x. 4 times 1 is 4, and we have a 5 here. So let's get to simplify. Combining like terms, -6 and -5, 3x minus 11. Combining again like terms, 8, that's not the right one, is it? That's 4 and 5, which is 9, so 8x plus 9. And I want to get my x's on the same side now. So notice I did the distributing first to make sure everything comes out the parentheses. Now I'm going to subtract 3x. And that leaves me with -11. Watch that negative stays there. 8 minus 3 is 5x plus 9. All right, so I want to subtract 9. That leaves me with 5x -20. All right, I didn't do this one over here. 12 times 6 is 72x. 12 times -2 is 24. Now let's see if we can combine anything. No, these are two different terms, but we can get our x on the same side by adding x here and adding x here. 70. Yeah, you can do that. So add x. 72 plus this 1x is going to give us 73x minus 24 equals 5. Add 24 on both sides. Gives us 73x equals, because that goes to 0. 24 plus 5 is 29. And we divide by 73. Divide by 73. Divide by 73. X equals 29 over 73. Not much you can do with that. I don't believe that simplifies to anything. I'll double check. I'm just going to look at it in the calculator just to see what it looks like. See if there's any decimals I recognize. 29 divided by 73. Nope, didn't really think so. So it's irrational. It just keeps on going on without pattern. Did we solve an equation with constants on both sides? Yep. With variables on both sides? Yep. With variables and constants? Yep. And using a general strategy. So the strategy I taught you, you can just kind of undo PEMDAS, right? You can just ask yourself what's happening to x on the left side and then undo it using your strategy. Guys, thanks for tuning in. I'm Brandon Clayton, the Algebra Guy, and I will see you next class.